Jason Chodachek. Jason has over 20 years of experience in the restoration and preservation of reinforced concrete structures. So help me give a warm welcome to Jason.
I'm going to be talking about cathodic protection jackets for marine structures. Why do we need cathodic protection jackets? Might sound like a simple question. Why can't we just go in and do some standard restoration work? Maybe just put a jacket on it. I'm sure that everybody in this audience has seen similar pictures to this. I think that these pictures are a little bit interesting here. We have areas within this picture, so we have areas that are within the wet zone or the water zone. We have areas that are up higher that are showing corrosion damage, and then we even have areas that are outside or up in the dry zone that are experiencing some corrosion damage. So I think that these pictures here show an example as to why we need cathodic protection jackets. But at the same time, it's showing a wide variety or a number of different areas that some of our substructure, some of the piles are affected. What types of, obviously I'm not going to be talking about all types of jackets here, but what types of galvanic or cathodic protection jackets are there out there? There's square ones that are white with some red wires. There's some red ones with some sticks in them. And there's other jackets that are above the water and they're round, and there's other ones that are in the water with some pipes on them in a box. And actually some of these jackets have bulk anodes attached to them and some don't. Some have larger bulk anodes, some have smaller ones. And so how are we going to decide what type of a jacket to use? How are you going to select what your structure is going to need? And so one of the ways that I would like to look at it, or what I'm going to walk through here, is the type of jacket or the type of a system that you're going to use is really going to depend upon the environment that it's in, or the exposure conditions that your piles are going to be present in. So one of the number one things that I think that everybody is aware of is we have kind of a saltwater environment. So especially here in Florida, with your saltwater environment, you have a tidal zone, you have your transitional or your splash zone. You also have your dry zone or your atmospheric zone, where you have your airborne chlorides where it's not wet, but you still have your airborne chlorides or chlorides that are present in the air that's still attached to your structure up there and are going to cause a problem. At the same time, there are brackish water environments, and a brackish water environment has very similar environments within it as well. I mean, it has a tidal zone. They're typically not as large. They have a splash zone, and that splash zone can be caused by either weather, environmental effects, or even ship or boat traffic. I know I've been involved in projects where structures have exhibited problems just because there was a jet ski boat rental place right beside it, and so it was continuing to get splashed by that. Other areas that you might not think of where you might use a marine type of a jacket system is a freshwater environment. And here there can be a number of environmental reasons why you may be experiencing a corrosion in a freshwater environment. It can be due to some industrial plants that are upstream, can be due to some contamination that was in the mud or some acidic environments. And then another area is a dry land environment. You might not think of this as a type of a jacket, cathodic protection or a CP jacket environment. But here we have piles, we have a substructure. We're going to probably have chlorides in some of these structures because we have de-icing salts. And at the same time, there's going to be some moisture that's present. And so this is just another example of all of the different environments, and how are you going to select what type of a jacket system or a cathodic protection jacket system you're going to use in this type of an environment or structure. So I'm just going to go through some of the exposures. So with all of those, with the salt water, the brackish water environment, or all these other environments that I talked about, you kind of have some typical exposure conditions. And here we have our underwater area. So this is an area where we don't have a lot of oxygen present. It's always wet. And we also have the seawater, or we have water here that can act as an electrolyte. We can move up to our tidal zone. This is a zone where we have our tide that goes up and down. Now, regardless whether it was the salt water or a brackish water condition, you're going to have varying heights of tide. But here we're going to have a lot of oxygen present, and we're going to have a lot of moisture. And this is a cycle that's just going to continue over and over. Then as well, we move up a little bit higher and we get into our splash zone. And this is either due to storm events, or it can be a number of other events. It could be boat traffic, ship traffic. But these are areas that don't typically see a lot of wetting, but periodically they do. And so it could even be due to, for example, in Florida, you may have a hurricane event that might only happen every 3 or 5 or 10 years. But you can get some contamination or wetting in those times as well. And then the final zone, or the final area, is our atmospheric, or our dry area. And this is an area that is dry. It is not exposed directly to any of the direct wetting from it. And it is the only thing that it's really going to be exposed to is possibly your atmospheric chlorides. And the one thing to note about all of these different areas or conditions within this structure is that all of these areas can be corrosive. They can basically put your structure in a condition where you can have corrosion of your reinforcing steel. And so you have all of these conditions that are, or environments that can be corrosive to your structure. And so what does this have to do with the type of jackets that you're going to select? Or what type of a galvanic CP system you're going to select for your jackets. And what you're going to do is you're going to try to use your environment to your advantage. And so in all of these systems here that I've talked about, we're using zinc. And so zinc is very active in a low pH or in a high pH range. And so what we're going to do is we're going to want to use, or we're going to want to take advantage of zinc in these ranges where they're active, where they're actively corroding, and they're able to provide a galvanic current. So in a couple of the examples, I talked about the saltwater, or the saltwater example, or even a brackish water example, is we have salt that's present. And so in this situation, it's not the silent killer, it's actually helpful to us. So salt is a very, very good activator, and if we have salt in our environment, we can use this salt as an activator, and we can keep zinc in an actively corroding state, and therefore we're able to pass galvanic current, and we're preventing our zinc from passivating and going into basically a shutdown state. So we can use this for a variety of the different jacket systems that are available. So there's some mesh jackets, and there's some wicking jackets, and I'll be talking about these a little bit further on. And now what if we get into an area where we do not have salt that is in the environment? So if we don't have salt that's readily available, we don't have salt that's present to help us activate these systems, how are we going to keep them active? Well, if we look at zinc, and if we look at our corrosion rate basically versus our pH chart, if we look at zinc, zinc is either very active in a low pH, or it can be very active in a high pH range. And it just so happens that steel doesn't want to corrode very well in a high pH range either. So what we're going to do is we're going to take advantage of this range here, and we're going to use an alkali activated, or basically take our zinc and put it in an alkali activated environment so that it will keep the zinc in an actively corroding state and be able to provide galvanic current. So I'm going to go through now and just talk about various types of CP jackets that are available. So some of these you guys may have come across in the past. So I think one that's been around the longest, I'm going to talk about this one first, and we'd call it the zinc mesh jacket. And this is a jacket system that's going to be used mainly for our tidal zone protection. It has basically an expanded zinc mesh that's going to be inside of a stay-in-place form. It's going to be fitted inside of the stay-in-place form. It has an open bottom, and it's going to be placed around a pile, and the salt water is going to move up and down within your tidal zone. And that salt water, if you remember back from when I was talking in the previous slides, it's a very good activator. So this salt water is going to keep the zinc in an activated state while providing, so it's going to allow the zinc to provide a galvanic protection or galvanic current to your structure. At the same time, we have our wet zone that is typically, below our pile jacket here, or below the zinc mesh. And what we're going to do is we're going to take advantage of the water that we have. So the pile was sitting in the water. We have our seawater, our salt water. So it's a very good electrolyte. So we're going to use a bulk anode below this and attach it to it. And so the bulk anode is going to be activated as well by the salt water, and it's going to be able to provide galvanic current to everything below the jacket system. So here's just a detail of a jacket, traditional mesh jacket. We got our jacket, we have our mesh, bulk anode, and so we have our high tide. So everything above our high tide was essentially our dry zone. We have our low tide, so we have our wet zone. And so we have our bulk anode here that's providing everything, or galvanic current, to everything below in our wet zone. And then, at the same time, we have our tidal fluctuation here. And so we have our tide that's going up and down, remember, with our salt water with the chlorides in it. And so this is providing activation to our zinc mesh. And so the zinc mesh is now in an active state. It's going to be providing a galvanic current and now protecting the area of the pile. And a mesh jacket, a zinc mesh jacket system, is most effective in this tidal range. Once you start getting up far outside of the tidal range, it starts to become a little less effective. Obviously, because there's no salt water present to keep the zinc in an active state. So here's just a few pictures of a standard zinc mesh jacket. So they're installed here, and you can see where the water is wicked up and down, and so it's wicking up inside this jacket and keeping the zinc in an active state and providing that current. The next type of a galvanic or a CP jacket that I'm going to talk about is it's a zinc fabric or a wicking jacket. It's similar to the mesh jacket system in the way that it's using zinc to provide a galvanic current. And here what we're going to do is we're going to use, instead of an expanded zinc mesh, we're going to use essentially solid zinc cores, and they're going to be wrapped in a sock or a wicking fabric. And at the same time, there's going to be an open bottom, there's going to be a stay-in-place form that's going to be put around this, and there's going to be an open bottom. And the salt water is going to be the activator here. It's going to wick up and down inside of this jacket. And again, you can use an optional bulk anode as well. If you have areas below your CP jacket that you want to protect, you can use a bulk anode for this as well. And so here's just another overview of the system. So we have our high and low tides. So we have our wet zone, so we're going to use our bulk anode here to protect everything below the pile if that's required. And you can see here we actually have, for these wicking anodes, what there is the sock or the wicking portion is sticking out through the bottom of the jacket to allow the salt water to get inside of the jacket system. And then we have our high tide, and then we have our dry zone. And so what's going to happen is we're going to have our tidal fluctuation that happens in here. Well, at the same time, we have our capillary action that's also pulling the water or the salt water up even higher than a traditional zinc mesh jacket would. And so then with this, we're going to have our effective area, which is going to extend out, reach out a little bit higher than that traditional zinc mesh jacket did. And here's, this is just a couple of pictures of what the system looks like. And so we have just a zinc anode. It's going to be wrapped in a wicking fabric. Or a sock, as I like to call it. And it would be no different than if you wore your socks in the bathtub. And obviously you're going to have water that's going to start to wick up your socks or your pants, or if you ever walk in wet grass, right? I'm sure everybody's had that happen to them once. And maybe a few people today. But here's the bulk anode. That's a typical bulk anode. In this picture here, it's a 48-pound bulk anode, but they can be of different sizes. And then there's just a C-channel with some threaded rod, and it's attached below the jacket system. Now, regardless whether it was a mesh system or a wicking system, it's attached below it. And then another thing to note is the bulk anode is then going to be wired into the system, so it can be all tied together to protect all the reinforcing steel within the system. And then the system, the jacket system, the stay-in-place form system's put around it, and it'll be pumped. So sometimes there's pumping ports. Sometimes if there's space, they can use a pipe and basically pump it from the bottom up as well. There's various methods for that. So the next system that I'm going to talk about is, what if you have piles or you have a structure that's corroding, but you don't have a wet environment or an environment with a number of chlorides in it, so you cannot rely on the chlorides to keep your zinc in an active state or actively corroding. So what we're going to do with that is we're going to rely, as I mentioned before, we're going to rely on the high pH or a high alkaline environment, and we're going to keep our zinc in a high alkaline environment, and that's going to allow the zinc to remain active. Well, at the same time, when it's active, it's going to be passing a galvanic current. And so one thing to note with this type of a system, since we're not relying on salt water, you can use it in a saltwater environment, you can use it in a brackish water environment, a fresh water, or a dry environment, because we're not relying on that salt water to keep it activated. And again, if you are using it in a situation where you do have water that is below it, again, you can use the bulk anode in this instance. So here's just another overview of what the system is. So we have our high and low tides, we have our wet areas, we have our dry area that's up above here. So we do not have any water, we don't have any chloride contaminated water, any seawater that is able to wick up and down within this jacket. So for all intents and purposes, this could be on a highway up in Minnesota. And it could be along the side of a highway, and you might have salts from the roadway. A snow plow goes by and it's blowing snow over onto the columns, and you're going to get deterioration from that. So you don't even have to it doesn't have to be in a marine environment for this type of a system to work. So you could even install this system in a dry environment on the side of a roadway as well. And then, so you don't have the salt water, so we're relying on that, on the high pH or the high alkaline mortar to keep the zinc in an active state. Then there's just got a couple of slides here of some of the activated systems being installed. So here, the activated anodes are being installed around a structure here. They're all going to be wired together. One thing to note that I didn't talk about in some of the other slides is here they've exposed a continuity strand here, or a continuity groove is what they would call it. And so what they're doing is they're going in there and they're going to measure the electrical continuity and make sure that all the reinforcing steel within this pile or within the structure is all continuous, because you want all of the steel continuous, because if it's not continuous, your system, your CP system that you install on here isn't going to be able to protect all of the steel or any of the steel that's discontinuous. You can see here they've had some spalled concrete, they removed that, and then what they did is they just put the jacket system around it and poured it back. Here's another example of a system. So on this example, there was actually arc spray that was applied to this, and it had reached its useful service life. And so in this project, they removed the arc spray, came in, they actually did a continuity groove as well. They wanted to make sure that all of the steel within here was continuous. Now, it's really close proximity to the water. This was actually more of a brackish water, probably environment. But even though you're still going to have ship traffic or boat traffic that goes by, so it's periodically going to get wet, but there's just not enough contamination or not enough salt water there that any of the other systems would function. And so this is why an activated system was chosen for this. And the area of concern is really just this lower portion of this column. They weren't concerned with the airborne portion or the dry areas up here. You were seeing a lot of corrosion that was occurring in here, so they were just focusing on this area. Here's some of the stay-in-place forms. So in this example, the alkali activated anodes are actually attached directly to the stay-in-place forms, whereas on the previous slide they were attached to the structure. So they're attached here. They're all wired up. Then they're placed around the column, and then there's a pumping port here. There's another pumping port on the other side, and the jacket system is filled with mortar, just a standard cementitious mortar. So this is what the system looks like when it was completed, and so you just have all the jackets in there. And on these ones here, there were junction boxes, so all of the activated anodes were all run up to this junction box. and then there was a steel connection or a cathode connection that came back from your reinforcing steel back into the box, and a connection was made. And you can actually open up these boxes, and there's various ways of monitoring and basically verifying the performance of these of the alkali activated systems. So I'm just going to kind of do a quick little review of some of the systems. So we have our mesh, the wicking, and the alkali activated jackets. Well, obviously we have our high and low tides. And so in both of these systems here, we're taking advantage of the chloride contaminated or the seawater, and we're going to use that seawater or the chlorides in the water to keep our zinc in an active state. Here it wicks up and down in the mesh jacket. Here it's going to wick up and down in the wicking jacket. It's going to extend up a little bit further. And then for the alkali activated jackets, we don't have to rely on this water or the salt water. So we don't need it at all. And so this is typically, it's going to be up in the higher or the dry areas for it. And so they all have their areas of influence. You know, we have here, it's kind of in the tidal zone. And as we get up here, it's in the tidal zone, a little bit higher up into the transitional zone. And then finally for the alkali activated jacket, it's doesn't require any of it doesn't have to be within the wet zone for that case, or does not even have to be in a marine environment. So, and you've seen all of the forms, the different forms. I was just going to show you a few pictures of the different types of the forming system that they use out there. So there's like two-piece forms, or there's modular forms. Here is kind of like a clamshell type of a form where it works with a tongue and groove connection, where you can just open it up, close it, uses an epoxy to seal it up. If you have some very, very long jackets, they get really hard to manage when you start installing the zinc mesh or the anodes on the inside of them. It can get to be quite heavy and be difficult to manage. So if you need to have a long jacket, you can have a bell and spigot. Here are some of the pumping ports that are typically installed on them as well. And then for some of the modular jackets, they basically come in strips and they can slide together, snap together. And you, again, just similar to the fiberglass forms, you can do square jackets or round jackets as well. Again, it kind of goes back to how are you going to pick the correct jacket? You know, what's going to be kind of your deciding factors and what type of a jacket system that you're going to use. And again, I think it comes down to, it's as simple as this. It's like, how are you going to keep the system that you choose, so whichever cathodic protection jacket system you use, how are you going to keep that in an active state? How are you going to keep it producing, you know, a galvanic current that can be beneficial to your structure? And so you're going to turn and look at your environment. So if you have salt water that's readily available, you're going to take advantage of that. And if you don't have that there, then you're going to have to go and look at alternate methods. And one of the methods that you can look at is an alkali activated, you know, using the high pH and keeping zinc in an active state there. And so I think that makes it fairly easy to determine what type of a system you're going to use. And here, this is just an overview. You have your mesh, which is your tidal, your wicking jacket, which can move up into your transitional a little bit higher, and then your alkali activated, which does not require any salt water. So again, the trick is we just want to make sure that the zinc does not passivate, and you want to keep it in an active state or an active corroding state.
What kind of lifespans are we looking for the CP jackets? Are they different for the different types, and mainly for the anodes?
Yeah, so what's kind of a typical lifespan? I think if you looked at just an average lifespan of it, you're looking around 20 years, you know, maybe a little bit more. Now, if you're looking to extend it a little bit further, you can add more zinc to it. So some of the systems you can do a tighter spacing. So the more zinc that you add, obviously the more availability or the more current that you can provide with it. So your structure is going to have a certain current draw, and so it's going to be designed around that.
On the two systems you had, one for the tidal zone and one for the transition zone, you seem to show a zone of influence, but you had them extended well above that. Why? Is there a reason to extend it well above that, or how would you decide where to cut it off?
Oh, as far as the protection, it's just I'm not really good at drawing, so that's where the arrows went. So there is a limit. There's a certain area of influence, and it's going to depend upon your tidal zone, and but it's going to reach up. You know, it's going to reach up a few feet above that. But again, it's going to be hard to determine just based upon your what your tidal zone is and so forth with that. But yeah, it's not going to go up 10 feet if that's what you're thinking.
There's no reason to extend it that far.
Right. Now, if you're wanting to extend a jacket up, he was asking whether or not, so if you do have damage on a structure that's extending up a lot farther out of that wet zone or that tidal or splash zone, that's when you're going to start to, basically your zinc is going to lose its activation. It's not going to remain active, and so you're going to have to look at more of an alkali activated system. You're going to have to use a system that's going to keep the zinc in an active state. So it is possible to use two different systems on the same structure or the same pile. So you could use a wicking or a standard tidal jacket below, and then switch to an alkali or an activated system above. Thank you.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.